Good morning, how you doing? This is MrDoTheMath here, and today we're going to talk about finding the area of polygons. Okay? In finding the area of polygons, there's some things that we have to know about. A polygon, so we're not just talking about any kind of polygon, we're talking about polygons with sides more than 4 sides, right? So with the polygon, you have some new vocabulary terms and things that you need to think about. The first word being this, which is the radius. This is called the radius. The radius is referred to as a radius because if you draw a circle along the outside of the polygon, when it goes from the center to a vertex, it lands on the same point of a circle, right? And so our radii are congruent. So if I drew one to this corner, that is also a radius, and it's congruent to this radius, right? And sidebar to that is the fact that then inside of this shape here, what's the name of this shape?
Hexagon.
Inside of this hexagon, you have an isosceles triangle, right? Now, going from the center of, and another thing about the radius is that it bisects this corner angle of this vertex here, so it cuts it in half, right? Now, a line going from the center of the polygon to the middle of a side is called the apothem. And the apothem is a perpendicular bisector, right? So it forms a right angle and it cuts the side in half, okay? Those are things that you have to keep in mind when you are trying to find the area of a polygon. And so we talk about inscribe and circumscribe. And so the apothem would be the radius of an inscribed circle, right? So if you were to draw a circle inside of the shape, it would be the radius, right? And so when we talk about word problems, those are little cues and clues and keywords that we'll find. So our new vocabulary word, apothem and radius, right? So we're going to take that and we're going to plug it into we're going to find areas using these things. It's important that we know what the apothem is and we know what the side length is. And so in order to find a side length, if we don't have it, we would have to use the skills that we learned, that we use to find sides of triangles when we were dealing with triangles. Again, this is an isosceles triangle, so if you drew an altitude through this triangle, you create our favorite figure, which is a right triangle, right? A right triangle, okay? And so within this right triangle, you have the apothem and you have the radius, right? All right, so let's get to doing some math, all right? Finding the area of a polygon, the most important thing in finding the area of a polygon is knowing what the formula is for the area of a polygon. All right, the formula for the area of a polygon is the apothem times the perimeter, which is the sum of all the sides divided by 2, right? And now we're going to look at what it would be to find these things in order to solve for the area. So let's use the same hexagon. Use the same hexagon, and I'm going to give you this side length of 18, okay? If you had just the side length of 18, how would we find the apothem? I don't know. So, what you want to do is pull a triangle from it, because triangles are what the focus was when we were trying to find the sum of the interior angles in first semester. So first and foremost, how would you find the sum of all of the interior angles? What's that formula? Do you remember it? N minus 2 times 180, right? So this is 6 sides minus 2, so it's 5 times 180. 5 times 180 is what?
With 6 minus 2.
How many sides is it? 6? So it's 6 times 180. Good catch.
No, 4.
4, right. 4, which is what? 720. Is it 720? Alright, 720. So that's the sum of the interior angles. But we need to know the measure of one angle, right? So we would divide 720 by what?
Number of sides.
By the number of sides. How many sides do we have?
6.
6. 720 divided by 6 gives us what?
120.
120. So that implies that the sum of these sides is 120. And now, again, like I said, the radius bisects this side. So if it bisects it, that means that the sum of this triangle is what? What's half of 120? 60. So you have 60 here. Alright? You use that to find this whole base length. Alright? So, like I said before, you'll draw an altitude, which is actually the apothem. We drew the altitude, and it'll help us find the measure of the height, the apothem. So we know that the base is 18, right? If the base is 18, then half the base is what? 9. So you got this side here. So you got 9, and this is a 30, 60, 90 special triangle, right? So if that's 9, this would be the short leg, right? What's the long leg?
9√3.
Yes, 9 times the square root of 3, right? So now we have the apothem, right? 9√3. So, in this particular problem, we have the apothem, A equals 9√3. Now all we need to do is find the perimeter, all right? The perimeter is going to be the number of sides times the measure of the sides. We know that we have 6 sides, and the measure of each side is going to be what? What's the measure of each side?
18.
Right, 18, okay? So we'll multiply that. 6 times 18 is going to be, in my notes, I got 108, okay? So we have the perimeter, and we have the apothem. We'll plug it into this formula here, okay? So area will equal 9√3 times 108 over 2. Alright, the most important thing to getting to this place was breaking down this triangle, right? Pulling out this triangle, Shantae, and then breaking it down, right? Creating this right triangle, alright? A hexagon gives us a clean situation because it creates a 30, 60, 90 special triangle, okay? You follow me?
Yeah.
Okay. So, 9√3 times 108 over 2 gives us what?
114.5.
What do you say?
114.5.
You got 114.5? I got something a little different. Let's calculate that. Anybody else? Anybody else? What'd you get?
I got 841.77.
Yeah. Yes, that's exactly what you should get. 841.77. Right. Alright. So again, so the first thing you want to do is you want to identify sides, right? Almost like your proofs, like what's given, right? Identify the sides. Draw your triangle, right? Then you want to basically solve for your right triangle. Solve for your right triangle, okay? And then find the perimeter if you don't have it, and then plug it into the area, and then you can find the area. Find the area, okay? So, we identify sides, what's given basically. We drew a triangle, and then we solve for the right triangle. So we solve for the right triangle enough to find our apothem, or you will solve for your right triangle to either find your base, okay? We all good so far? Yes?
Where did the root 3 originally come from?
The root 3 came from the formula of the special right triangle, right? 30, 60, 90? Remember that? This was 2x, this is x, and this is x root 3. X was 9. So then the long leg would be x root 3. Alright? Okay. Let's look at another shape. Let's look at this pentagon. Let's look at a pentagon. Let's look at a pentagon. Okay? And so my goal is to give you a challenging give you the challenging example, so then the book's examples are simple. If I give you a pentagon with this side being 8, right? With this side being 8. Alright? Now, in this particular example, well, let's just get to it. Alright, so we got this side being 8, and that's all we have. First thing you want to do is we identify the sides. All we got is 8. Now we're going to draw a triangle. So we're going to pull this triangle from this pentagon. And remember, all the triangles are isosceles. So we got this triangle with side length 8. Alright? That means that when you draw an altitude here, that each side here is going to be what? 4. They're going to be 4. Okay? The next thing we need to do to figure out, to solve for this triangle, or to find this apothem, right? Because this would be the apothem up here, right? From here to here is the apothem. We need to find out what the measure of these angles are. Alright? So, if this is 5 sides, we need to know what the measure of one angle is. So, using the formula, that's 3 times 180. What's 3 times 180?
540.
540. Alright? You divide, so 540. You're going to divide 540 from 5, and you're going to get what?
108.
100 and who?
8.
108. Alright, so the measure of each angle here is 108. Now, this radius bisects 108. So that makes the measure of this angle here half of 108, which would be
54.
54 degrees. Now, we got two things. We have an angle measure and we have a side length. What did we use with with right triangles to find this? Alright, so again, we have this side and we have this. We have to go back to our trig. So, ka, toa, so, ka, toa. Alright, so 54 and 4 is what? What's 4 in relation to 54?
This camera probably died.
It's the west side. It's the adjacent side. And we need to find this side, which would be the what? Opposite side. So which trig function is opposite, has opposite and adjacent?
Sine.
Opposite adjacent, TOA. Right. So now we have, so that's what we do to find x. So it'll be tan 54 equals opposite over adjacent. You remember that? So this is going to help us find out this height here. That's what you're going to have to do. Alright, so to solve for x, remember when it's at the bottom, you multiply. Right, so it'll be 4 times the tangent 54. I need somebody to give me that though. Somebody needs to work that out for me. Yes, sir.
5.51.
551. So 5.51 then would be the height. And that is also the apothem. I need to get your calculators ready so we can work this out now. So now we have the sides. We have the side lengths, which are 8 apiece. And we have the apothem, which is 551. So A is 5.51. And the perimeter is going to be 8 times 5. 8 times 5 is 40. So let's let's find the area of this figure. So it's going to be 5.51 times 40 over 2. Area then will equal what? You got it already?
Yeah, 110.2.
110.2. That is the area. Okay? So, that's what we did. We identified the sides, we drew a triangle. We solved for the triangle. We found the perimeter, and then we found the area. Alright? The most important thing, I think the newest concept would be to go all the way back to first semester to find the measure of each angle. And then when you draw your triangle, you break that angle in half, and you got your right triangle. Okay? Alright? Any questions? Any questions?
Yeah, what did you do? Because you're going like 100 miles per hour and I'm lost now.
Oh, okay. Well, we'll be okay because you get to watch it again. Alright? Yes, sir.
Earlier you mentioned how a circle inside a hexagon relates to like radius and apothem. I don't get that.
Oh, this is just, it would be, so if again, the most important thing is getting to the triangle part, right? The radius is going to be the hypotenuse of your side, right? And so the conversation about like either a circumscribed circle or an inscribed circle will be based on what they give you. Sometimes they'll say it's the radius of the circle circumscribed to this would be something. You know that the radius of the circle of a circumscribed would be the side of the triangle. And if it's inscribed, the radius is going to be the apothem. Okay? That's just extra details. Okay? But the most important part is just being able to identify what you have, what you're working with, right? Once you know what you're working with, you can get to where you're trying to go. You're trying to get to the area, right? And so as long as you have the information that you need to get to the area, then we're going to be okay. Yes, sir.
So which one is the radius is the circumscribed one?
It depends. So you got circumscribed. When it's circumscribed, the radius is the hypotenuse. When it's inscribed, the radius is the apothem. Inscribed means inside of the polygon. Circumscribed means outside of the polygon. Okay? Again, those are just details. So they're saying, hey, this is the apothem, or they're saying, hey, this is a